Alright, I'm going to take you through how to go from the basically grams of a substance to atoms of a substance. And then don't get confused, we use the word molecules when we're talking about compounds. So you can go from grams to molecules as well. So in fact, I may just go ahead and do molecules so that way we can kind of encompass everything. So like let's say for example I have, let's say that I have 55.5 grams of, let's say I have copper 2 chloride. And I want to figure out how many molecules that is, which is, it's the same thing as atoms. We're going from basically grams to atoms, grams to molecules. It's the same thing. So you're going to do a fraction. Okay. And so we're going to put what we're trying to get rid of on bottom, which is grams of CuCl2. And we're going to put what we're trying to, now this is going to be a two-step process because you can't go straight from grams to atoms. You have to go from grams to moles first. So we're going to go to moles of CuCl2. So 1 mole. Okay. So that's our first step, is going from grams to moles. Now, the grams, normally we would just look up the grams on the periodic table, but we have 2 elements. So I'm going to go down in my think area and go, okay, I have CuCl2, so I'm going to have to calculate the molar mass. So I have copper, I have chlorine, I have 1, I have 2, times, copper, the mass of that is 63.546. Chlorine, I have the mass of 35.453. Okay, and so basically this mass of copper stays the same, right? 63.546. And then the bottom one is 35.453. Take it times 2. So that's 70.906. Add them together. Plus 63.546. 134.452 when I add them together. So sig figs, let's see. This one has 3 after, so I'm going to have 3 after, so that's a good number. So now I'm just going to go and I'm going to put that number up in my problem. So I use 134.452. I kind of ran out of room there, but that's okay. It happens. So now you're ready to do a secondary fraction, where you get rid of the number of moles, because I don't want moles, I want to go to, my goal is to get to molecules. Okay, so I'm going to go from moles and I'm going to go to molecules, and unfortunately there's not abbreviation for molecules. Okay, and the 1 always goes with the mole for now. So you go 6.02 times 10 to the 23rd. Okay, so that's filling everything in there. Okay, and I guess the title's kind of bugging me for the moment. I know it's not probably a big deal. So, or grams to molecules. I feel like that's going to bother some people. So I'll fix that for some. Alright, so now we're just ready to do the math. So you're going to take your 55.5 in your calculator, multiply it by 6.02 times 10 to the 23rd. Then you're going to divide it by 134.452. I get a calculator answer of 2.4 8, 4, 9, and some more answers, times 10 to the 23rd. And I'm just going to double check that to make sure that, makes sense. Yeah. Okay. Sig figs, I go back to the given. I have 3, so my answer can have 3. So let's see, I have 1, 2, 3. Look next door, it's 4, so it's going to stay the same. So my answer should be 2.48 times 10 to the 23rd. And the label should be molecules of, in this case, CuCl2. And that's basically the setup. I mean, if you go from, molecules to grams, it's just a flip of that entire process. So, there's a grams to atoms or grams to molecules type example.